Hello everyone, welcome to Learning with Vodafone webinar series. In this webinar, we are going to talk about Module 3, which is based on application programming. Under this module, we are going to discuss how to implement an IoT-based home automation system using Raspberry Pi. So today we are going to learn about the designing of IoT-based home automation system using Raspberry Pi. We will try to understand how can we use Internet of Things along with Raspberry Pi to create a home automation system where we can control some of our home appliances with the help of the IoT. Embedded systems were basis of many devices which gives real-time behavior and performance independently. Many of the big systems can also process huge chunk of data and can give best of results, but they also work standalone. Sometimes these devices talk to each other with certain predefined communication protocols. IoT have taken it one step further in continuation of machine-to-machine interaction over specialized communication networks, storing sensor information, analyzing data, and assisting individuals to take calculated decisions through cloud technologies. Here we can observe a IoT ecosystem where in the very first stage we have a device connection and connectivity where your device is connected via sensors to the different scenarios. And in the next step, we have a data sensing and collection, where the sensor helps to collect the environmental data or the data of a necessary target object. And the third stage is your data transport. So once we get our data from our sensors that we have collected in the stage 2, so that is being transported by certain protocols to some of the servers or some of the base stations. Then in the fourth stage, we make our data analytics, where we understand about that data, where we try to analyze that data, where we try to clean that data, where we try to understand some relationship between those data. Then in the next step, we have data value defined by the action. So based upon that data, we try to conclude that what could be the possible actions, which like predictive analysis we are doing in this stage. And then the sixth step is there where you have a human value, apps and experiences. So this decision that we are taking up in this stage would be helping to generate a better human value and experiences which will benefit the society as a whole. This is another picture of an Internet of Things ecosystem where we have IoT devices available here, which is exchanging its data that these devices have collected via sensors to the gateways. From the gateways, that via internet network, that data is sent remotely for analysis, or it can be sent to a data storage where the data could be stored and analyzed further over the cloud. So this data storage is over the cloud, whereas here we are trying to send the same data to the remote servers where it can be monitored, observed and predicted based upon the incoming data. Notice we have a bidirectional communication between the gateway and the remote servers or the data storage, so that whatever analysis have been done on that data, with the help of that analysis, some predictive actions could be taken up which can help the society in general. Now in this application, we are going to connect two appliances to Raspberry Pi whose status can be retrieved by user via Twitter. In case user wants, he or she can turn off respective appliances via his Twitter account. Log status of appliance could be continuously recorded and stored in the Dropbox data server. So basically in this application we are going to perform three different tasks. First is to create a log status of the devices or appliances that we have connected to our existing system. All that log files would be stored on the system itself with its timestamp. Controlling appliances over global network using HTTP protocol via Twitter. And finally, once we have controlled our appliances, once we have done whatever we wanted to with our system, whatever is the log that is being created, so that log file will be uploaded to the data server, and we are using our Dropbox in this application. Since we are going to perform three different tasks, for each of the tasks in this application, we are going to create threads where those threads will be responsible for their individual actions and they would be communicating with each other for a concurrent behavior. Since we are going to use concept of multi-threading in this application, let us first briefly understand the concept of threads. In computing, a process is an instance of a computer program that is being executed. Any process has three basic components. First one is an executable program. The second is the associated data needed by the program, such as variables, workspaces, buffers, etc. And the third is the execution context of the program, which talks about the state of the process. A thread is an entity within a process that can be scheduled for execution. It is the smallest unit of processing that can be performed in any operating system. In simple words, a thread is a sequence of such instructions within a program that can be executed independently of other code. For simplicity, you can assume that a thread is simply a subset of a process. Running several threads is similar to running several different programs concurrently, but with the following benefits. Multiple threads within a process share the same data space with the main thread and can therefore share information or communicate with each other more easily than if they were separate processes. Threads sometimes are called lightweight processes and they do not require much memory overhead. They are cheaper than a normal regular process. In Python, the threading module provides a very simple and intuitive API for spawning multiple threads in a program. As in any Python class, __init __ will initialize and set up the properties of the class with the help of its attributes. To start a thread, we use start method of thread class. Once the thread starts, the current program, which you can think like a main thread, also keeps on executing. In order to stop execution of the current program until a thread is completed, we use join method. As a result, the current program will first wait for the completion of the thread 1, and then thread 2, and then thread 3. Only when all of them are finished, the remaining statements of the current program are executed. The threading module has the thread class that implements threading. The methods provided by the thread class are as follows. The first is the run method, which is like the entry point for a thread. Next is the start method, which starts a thread by calling the run method. The third method is join, which waits for the thread to terminate. Another method is alive, in case you want to check whether a thread is still executing or it's terminated. Next method is getName, if you want to return the name of a thread. And finally, we have a setName, if you want to set the name of a particular thread. To implement a new thread using the threading module, you have to do the following steps. First, define a new subclass of a thread class. Second, override the __init __ within bracket self and args method to add additional arguments. Then override the run within bracket self, args method to implement what the thread should do when started. Once you have created the new thread subclass, you can create an instance of it and then start a new thread by invoking the start, which in turn will call run method. A thread has a beginning, an execution sequence, and a conclusion. It has an instruction pointer that keeps track of where within its context it is currently running. Threads can be preemptive in nature, that is, it can be interrupted. Threads can temporarily be put on hold, also known as sleeping, while other threads are running. This particular behavior is also called as yielding. Thread synchronization. The threading module provided with Python includes a simple to implement locking mechanism that allows you to synchronize threads. A new lock is created by calling the lock method, which returns the new lock. The acquire, we also call this as blocking method, of the new lock object is used to force thread to run synchronously. The optional blocking parameter enable you to control whether the thread waits to acquire the lock. If blocking is set to 0, the thread returns immediately with a 0 value if the lock cannot be acquired, and with a 1 if the lock was acquired. If blocking is set to 1, the thread blocks and wait for the lock to be released. The release method of the new lock object is used to release the lock when it is no longer required. Here we can observe the physical connectivity between the Raspberry Pi and the appliances. For the demonstration purpose, instead of regular appliances, I have used normal LEDs, and in that case, the 16th number pin of Raspberry Pi is connected to the positive terminal of my LED, whereas the 13th number pin is connected to the negative terminal of the LED. The 6th pin, which is a ground pin in Raspberry Pi, is connected to the switch 1. So this is a case for the appliance 1. Similarly, 18th number pin of Raspberry Pi is connected to the positive terminal of the appliance, whereas 15th number pin is connected to the negative terminal of the appliance, and pin number 6 is also connected to switch 2. Since here for the demonstration purpose I am using LED, I can directly connect them to Raspberry Pi pins. If you are using a regular appliance, you should connect these Raspberry Pi pins first to the relay, and from relay only you should be connecting it to your regular appliances, or else your Raspberry Pi may get damaged. This is an image where I have demonstrated what is connected where. So here you can notice that the 13 number pin is connected to the negative terminal of the LED, whereas the 16th number pin is connected to the positive terminal of the LED. This is your 6th pin from where we have taken the ground, and this ground is connected to the one of the legs of the switch. So this switch is acting as a control to the appliance, that is LED. The other leg of the same switch is connected to the negative terminal of the LED. So the idea is, when the switch is pressed, at that time this ground signal would be reaching to the negative terminal of the LED. At that time, this particular 16th pin, which is already high, will make this LED go on because the circuit completes. Whereas when the switch is not pressed, this ground will not reach to the negative pin. So even though the supply is available for the 16th number pin, this LED will not be on. Now in case user wants to forcefully turn off this particular appliance, so user can send a signal from 16th number pin to the positive terminal as 0. So in that case, even though the switch is pressed, which is bringing the ground potential to the negative pin of the appliance, but since 16th number pin is not providing supply, so in that case the appliance will not turn off. So no matter whether your switch is pressed or not, by providing appropriate potential from the 16th number pin, it may be 1 or 0, you can turn off your appliance. So that is the basic working principle behind this experiment. For the sake of simplicity, I have demonstrated only one appliance as a LED so that you can clearly see the connectivity. The same can be repeated here, and we can name that as appliance 2. So next is, in case you want to fetch the IP address from the Raspberry Pi. So for identifying the IP address of the Raspberry Pi, there are many methods available, such as Angry IP Scanner, or you can use the command prompt. For my case, I used to prefer command prompt when I'm working on Windows. So in that case, you need to make sure that your Raspberry Pi is connected with Ethernet cable and the other end of your cable is connected to the laptop. Then we need to go to Network and Sharing Center. So let me demonstrate this actual phenomena, which will help you understand that how can we fetch the IP address from the Raspberry Pi. So what we do is, we go to our network, go to Wi-Fi. Here you will find Network and Sharing Center. Click on this. You go to your connection. So I'm using a Airtel Wi-Fi. So I'll click on this. I'll go to Property. Here I'll find another tab called Sharing. So I'll click on the Sharing tab, and I have to make sure that this particular tick mark is available. Only when this tick is available, then only your Raspberry Pi would be able to talk to your laptop. Once this tick is done, you go back, open your command prompt, and in this command prompt, you type a command ARP space -A. Hit enter, and here you'll get various IP addresses. So the problem is exactly which IP address you are supposed to look into, like 192.168.137.127.126. You have so many IP addresses, so sometimes it may confuse you. So to verify what would be my Raspberry Pi's IP address, again you can go to your network, Wi-Fi, network and sharing, go to this Ethernet. So click on this, go to property, go to IPv4. Now here you will find something like 192.168.137.1. This one is of no use to us, but at least we got to know that this is the IP address which is being shared with my Ethernet, that is 192.168.137. So we'll take this into account, and here I need to check exactly where is it. So here I can find 192.168.137.15. So it means, so this 15 is the IP address of my Raspberry Pi. So at this moment, what you can do is you can open your PuTTY. So I've already connected my system with that. Let me disconnect it first. So you can open your PuTTY if you have installed. So I'm using PuTTY. You can use Teleterm also in case you are interested. And here you need to type this IP address 192.168.137.50. Make sure it is on SSH. Click on open. It will ask login as. Give the username as Pi and the password is Raspberry. This is a default password. You can update your password in case you require. So you can see here that I have entered into my Raspberry Pi account. I hope you have understood how to connect to your Raspberry Pi. Now the next step is that you need to configure your Wi-Fi network on Raspberry Pi. Since you want that your Raspberry Pi should itself talk to your available Wi-Fi, it should not share the network of your laptop. So in that case, you need to visit to this particular file, that is /etc/network/interface. Open this file using whatever editor you are comfortable with. I am using Nano. And in that particular file, this should be the available text. 3-4 lines would already be available. Here exactly you are supposed to make the change. So here you need to specify exactly what is the network to which you want to connect, what is your Wi-Fi network, and what is the password of that network. Once you make this change, save it. And after saving, you have to type this command sudo space systemctl space daemon-reload. Hit enter. Once you do that, your network interface would be restarted, and probably now you are able to see your IP address in WLAN 0 configuration when you type ifconfig command in your Raspberry Pi. Once you have got your IP address, then you can further check using ping space google.com command. So you should be getting a response, something like this. Here if I type ifconfig in WLAN 0, I am able to see the IP address that I have for my Raspberry. And if I say ping google.com, you can notice my system is responding. In case you want to verify that whether this particular response is coming actually from Raspberry Pi or Raspberry Pi is sharing my laptop network, so what I'll do is I'll just disconnect my network from the laptop. So now you can see that my laptop doesn't have a network. So now if I repeat the same command, yes, so here you can see that even though my laptop doesn't have a network, still my Raspberry Pi is responding back. So this response is coming because my Raspberry Pi is directly connected to my existing Wi-Fi. Fine. So let me connect back to my network. Now the next step is to create a Twitter account. So in case you have not created your Twitter account by now, so this is the time you should go and create your Twitter account, because we are going to use Twitter as a medium to provide necessary commands to our Raspberry Pi. So create a Twitter account, make sure that you have done your mobile and email verification. Once you have done, click on this link and go to the developer page. So I'll just show you this tech page. So this is my Twitter account. I can copy that link and I'll just paste that in my address bar. Hit enter. and it will take me to this page. Here you can notice that's my account, and in your case you might not get all the stuff, so you'll be getting a tab of create an app. You can click on this tab to create an app and complete all the formality. It may take some time to get your app available. So I already have my apps available with me. I'll show you the things that you are supposed to do. So once you got your app, so get into your app and you will find these three tabs. So our intent is to go to keys and tokens tab. So here you are supposed to copy these two consumer API keys and these two access token secret keys and note it somewhere because we are going to use that in our program. So next step is Dropbox. Now you're supposed to create an account in your Dropbox if you don't have it at this moment. This is my Dropbox account. You're supposed to go to this three dots. Click on this and go to developers. When you reach here, you will get a page from where you can create an app in your Dropbox. You can go to My Apps. Here you can click on this to create an app. Since I have already created an app, I'll go to my app and in the settings, you scroll down, here you get the option of generated access tokens. You click on this generate and it will give you an access token. You should carefully copy this access token because we are going to use this access token in our program. Now you might be thinking that exactly why we are into these tokens and keys. So with the help of these access tokens, consumer keys, our program will be able to interact directly with our Twitter and Dropbox account without our intervention. So it's like a username and password that we are going to provide to my program, where my program will be fetching some data on my behalf from my account and make necessary changes. You can download the reference material for this webinar from the given link. To complete this webinar, your computer or laptop must have Ubuntu 16.04 LTS available. In case you are using Windows-based system, VMware Workstation or VirtualBox will not work for this particular application. So don't use any of those virtual systems. So either stick to Windows or Ubuntu that you have installed on your hard disk. For the convenience of this webinar recording, I am going to implement this application using Windows. There are certain hardware requirements for students to complete this application. The first is the student must have either Raspberry Pi 2 or 3. They should have a Raspbian OS which is installed in their SD card and connected with their Raspberry Pi. Students should have breadboard, Ethernet cable, 2 LEDs if they are going to work with 2 appliances, 2 switches, 10 wires, where 6 will be female to male and 4 would be male to male. Now let me quickly take you through the code where I'll explain that what's happening there, and then we will see a live demonstration. So here is your actual Python code for this application. We are going to import Raspberry Pi.gpio as GPIO so that we can access the Raspberry Pi GPIO pins. We are setting the mode of the Raspberry Pi, telling that I'm going to access the GPIO pin in the board nomenclature, not as a Broadcom nomenclature. We want to disable any of the warnings that might happen. Since I'm going to use pin number 13 and 15 as inputs, so we are assigning them as GPIO.in, whereas 16 and 18 number pin I'm going to use as outputs, so we are taking them as GPIO.out. 16 and 18 number pin are by default made true, so they would be giving you the positive out in the beginning. Then we are going to import certain libraries that we might require in our program. So you can notice a threading library because of the multi-threading application, logging library since I want to log my data, and I'm importing Dropbox library since I'm going to use Dropbox. I'm going to import Tweepy since it will help me to deal with my Twitter account, and system libraries. Then we go to this place. So here we have a try and accept function where by default the program would be attempting first in this area of this code. And here it is saying that my thread underscore log. So these are the functions we are going to call to create our threads. So we are going to create 3 threads. One thread is for the logging, one thread is for the tweeting, and the one thread is for uploading. So these are the arguments we are passing. So these are the thread IDs we are sending. These are the names of the threads, and these are the counter values or the delays that I want to provide to each of the threads. So once I say my thread underscore log 1 comma log comma 1, so let's see what's there in this particular function. So at the end of this particular function, your thread 1 is created. So I go to my thread underscore log, which was in the beginning. Here we are calling threading.thread, where thread is a class under module threading, and we are calling underscore underscore init underscore underscore, which will initialize and set up the properties of the class with the help of its attributes. So attributes are, so the default attribute is self, which is always there with every underscore underscore init underscore underscore function. Then we have other attributes as thread ID, name, and counter. So we have passed thread ID as 1, name as log, and the counter value would be 1. Now here we are assigning the thread ID to self.threadID, self.name as name, and self.counter as counter. So each of these functions, as we have already specified, that each of this init function will have its run method that will help to implement the thread what it should do when it gets started. So when this particular thread is started, it will implement this method, and what it will do, it will first print that starting plus self.name. So self.name is nothing but log. So it will say starting log. So this thread log.acquire and thread log.release. So this is the functions we are using to synchronize the threads. And in this particular method, it is calling a function log with the arguments as self.name, self.counter, and 1. So this is the function that is available. Now in this particular function of log, so self.name is nothing but the name of the thread, that is log. Self.counter is the value that we have passed, that is 1, which goes to the delay argument, and this 1 goes to the counter. While counter, when the counter value is 1, so it will print logging status. And here it is calling a function logging.basicconfig. So this is the function which is coming from the library logging that we have imported. And here we are specifying the file name as demo underscore log file.txt. This is the actual file name in which we want to create our log that would be stored in our Raspberry Pi. And this is the same file we are going to upload on the Dropbox. So here, with the help of this AST time, level name, and the message, we are trying to fetch the current date and time, and all those stuff along with the any possible message would be recorded in this particular file. Once it is done, once your log is created, then we reach to this point, and here we are saying that gpi.input13, we are trying to read from the 13 number pin the status in the x variable, and if the variable is true, so we say log.info as light is off or light is on. So by default, this particular pin is used as an input pin, and this is connected to ground. So by default, this particular pin is used as input, and if the switch is pressed, then only the negative terminal of your appliance would be connected to the ground. Otherwise, it will be on the high impedance state. So once you are reading it, if it is not connected to the ground, that is, it is into the high impedance state, it will say light is off or it will say light is on, and this message will also be stored as a log into your file demo underscore log file.txt. Similarly, here we are saying gpi.input for 15, so this is for the appliance 2, and we are recording a similar kind of a message that whether your next appliance is on or off. So this is the thread which is responsible to create a log file and store the current status of your appliance in the file named demo underscore log file.txt. Then we move to the next thread. The next thread is my thread underscore tweet. And this time your ID is 2, the name is access Twitter, and the delay is 2. We pass these arguments to the thread mythread_tweet. So the same thing is repeated here as well. So we have a class mythread_tweet. We say threading.thread def__init__. It's very similar to what we have seen just now in mythread_log. This section is very much similar. In the run section, we have another function called search_tweet, and the arguments are self.name. So this time the name would be access Twitter, self.counter. So counter is your 1, and this is 1. Now we jump to this function of search tweet. Here we have this access name, this access Twitter goes to thread name, counter 1 goes to delay, and this 1 goes to this counter. Now while counter, so when your counter is 1, you call a delay. Here you can notice the role of this delay argument that you are passing there. So it means your second thread, this particular thread would be executed after the delay that you have specified in your arguments. Then here you are printing a message, searching in Twitter, and at this particular place, you are supposed to punch in your consumer API keys and access tokens and access secret tokens that you have copied few minutes back. So these are my keys, so please don't use these keys, otherwise you won't get the response. Then you call this tp.oauth handler c key, c secret. So with the help of this particular library of TWP, we are calling a method oauth handler. It is using the consumer key to validate that these keys are coming from the valid application, and then it is using auth.set_access_token as a token, a secret. So with this, it is trying to validate that this particular app, which is genuine, so whether that app is used by the correct person or not. So because every app that is created by my account should belong to me only. So it should not happen that the app belongs to someone else and I am the user of that app. So once that validation is done, then here in this function for tweet in tp.cursor, it is going to search for a specific string. So we have specified a string 14826-light status. This is the exact string that I am supposed to tweet in my Twitter account, which my Raspberry Pi would be searching. And in case it gets the message, then it will do something. So let's see what it will do. Here it says response equals to tweet.text and print response. So with the help of this, we are trying to see that what is the exact response that this 14826-light status, whether my system have recognized this string in my account or not. Now it is trying to read the status of my 13 number pin into X variable, and it tries to say that if X equals to false, it means that the switch is pressed. Then only it will get false status. Otherwise, if switch is not pressed, it will get a high impedance as in the previous case. So if it is false, it will update the message that light is on. So it is trying to read the status of the 13 number pin from here, and it is once it have read, it is time to verify that whether this particular 13 number pin is giving false or true. If it is giving false, it means the switch is pressed because my appliance is getting the ground potential on its negative pin. So it will say light is on. So it will make this tweet, and then it will say API.destroy status, so that this particular message that user have sent would be destroyed, which is available in this particular ID, so that in the next iteration my system should not see the previously sent message and respond. Every time once it is taking the message, after reading the message, it gives you an output, and then it destroys the previous tweet, and then it is creating a log entry that light is on. Else, if the value of X is true, it means it's a high impedance state which is not pressed, then it will update the message light is off. So this is the response user is getting from the Raspberry Pi in his Twitter account. Then again it is saying light is off, it destroys the previous tweet, and then it makes a log entry as light is off. So this is for the appliance 1. Similarly, if the user says that tell me the status of the fan, it will try to read the status of the 15 number pin, and it will verify that whether the 15 number pin is true or false. False means switch is pressed, so it will say fan is on, destroy the tweet, make a log entry. Else, if it is not so, it will say fan is off, log entry is done, and destroy the tweet. There may be a situation that instead of asking light status, user sends a message 14826 light off. In case user wants to control the appliance via Twitter, so it will see the status, and here it says that again it reads the situation into the variable a. And it says that if A is false means switch is pressed, so light is on. But what it can do, it can say it can make the 16th number pin go false. So the moment 16th number pin of the Raspberry Pi go false, it means at the positive terminal the default supply is disconnected now. So at that case, the negative terminal will get ground and the positive terminal would be made ground by this particular statement. So circuit would not complete and your appliance will be shut down. And then it can make a tweet that light is made off by the user. Make a log entry and then destroy the previous tweet. So it will this particular tweet will be destroyed. Else, if this is not so, if A is true, so you ask to switch off the light and light is not on. So it will just respond that light is already off. Make a log entry and destroy the tweet. Fine. Similarly, it goes for the second appliance. So those are the details of your thread 2. And in the thread 3, which is for uploading the data on the Dropbox. So again, we are creating the thread. And the details of that thread is mentioned here. This section goes as it is. And here in the run function, we have a function called upload underscore Dropbox, self name, self.counter, and 1. So self name is your upload, counter is 3, and the value is 1. So you can use this 3 to give a delay in case you want to. Counter value is 1. And then you are printing a message uploading log to the Dropbox. So with the help of this particular function, Dropbox.Dropbox, and here is the access token that you have got from your Dropbox account. So please paste your access token here that you have already copied so that this program can interact with your Dropbox account. And then it will open the file that is available on my Raspberry Pi. Read that file, and with the help of this dbx.file underscore upload, it will upload this data that it have read into this particular directory as this particular file name, and make sure you mention this mode that you want to make a update. What does it mean? It means that every time you should not create the new file, but it should update the existing file. Once it is done, then you say counter equals to counter minus 1. The counter value which was initially given as 1 will become 0, and this iteration will not take further. It will move out for the next thread. So these are the details of all these 3 threads that you have created. To start these threads, so these are the functions that are being called one after another. Then in case you want to add thread to the thread list, we are calling this function. Finally, here, once all the threads got executed, here we are asking to join all these threads so that all the threads one after another they get terminated. Once all the threads are terminated, then it prints that exiting main thread, telling that all the terminations have been done, and again it will repeat the entire process. In case you want to break the flow, you can press Ctrl C, and that will act as a keyboard interrupt. It will call the function sys.exit to break the control, and you will come out of this loop. So this is the explanation of this entire program. I hope you have understood the code, and I have tried to make it as simple as possible, but it's a bit lengthy one and interesting application. So let's see the demonstration. So here I have this IoT logger named folder, which doesn't have any file within. The folder is empty. Fine. So let me clean my log file, which I have under desktop under Vodafone folder. Let's go there. Let me remove this file demo underscore log file. Just to make sure I have a valid file available, I'll use a touch command to create an empty demo underscore log file.txt. So if I open and show you this file, nano demo, this file is empty. Fine. I'll let me go back to my Twitter account from where so that I can tweet messages as required. Okay, so let me execute the program. I call Python, and the file name is iot.py. Hit enter. Notice here we are getting a message starting log, logging status, starting access Twitter, starting upload log. So all these three have been initiated. Then searching in Twitter is going up, uploading log to the Dropbox, exiting main thread. So first iteration is over. Again, it is repeating the process, starting log, logging status, all those stuff, third instance, and so on. So let me give us message 14826 light status. Notice it is case insensitive, so you can type in whatever format you want to. So I'll just make a tweet. Now that tweet is available here. Hopefully this tweet will be recognized by my program and my Raspberry Pi will respond something. So it is searching in the Twitter. Here it got the message 14826 light status. So it have recognized my message that I have tweeted, and in response to this, my Raspberry Pi have tweeted something. It says light is off. Fine. Now remember, this interaction is happening over global network. Okay, let me send a new tweet. And this time, before I make a tweet, I'm going to make my LED on or my appliance on by pressing the switch. I hope you are able to listen the sound. So this time, so I am pressing my switch, which have made my LED go on. Now my appliance is on. But what I'm going to say is, I'll say 14826 light off. So I'm going to pass a message light off via Twitter to the Raspberry Pi, and Raspberry Pi will turn off this LED that I have made on with the help of a switch. I have made a tweet. Just searching in the Twitter. Here I got a message from the Pi, light is made off by the user. So now, even if I am pressing my switch multiple times, but I am not able to turn on my LED, that is because this is made off by the Raspberry Pi by turning GPIO 16th number pin as low. Fine. Now, so one part is clear that my Twitter is able to talk to my Raspberry Pi, and Raspberry Pi is able to respond back to Twitter. The next step is whether I got my log files created. So let me close this process by pressing Ctrl C. So this will send a keyboard interrupt stopped by the user, and you have break the control. So let me see for this file demo underscore log file using nano command. Let's see whether we have some logs created or not. Yeah, so we have our log created, and you can see the time, you can see the date, you can see certain informations which are available. Whenever it is calling for a Twitter, it's using an API of Twitter, it is saying so. It is saying requesting to file uploads. You can notice it is giving your time, date, stamp, all those information is available. Fine. So detailed log is being created from minute to minute basis, telling that what is happening when. Okay. Now let's see that whether this log have been actually uploaded to our Dropbox. So we can go to our Dropbox. In the Dropbox, there's a file, demo underscore log file. If you click on this file, you find all the same details available, like date, time, and the information. At what time and minute, what was happening, what was the status, and so on. When the Twitter was accessed, when the Dropbox was accessed, right? So all that information is available with us. In case I want to know that what is happening when, I can do that. So I think I have made the complete demonstration of interaction of the Twitter with my Pi and Pi interacting back to Twitter. At the same time, Pi uploading the data on the Dropbox and creating its log file. So in this webinar, we have understood the concepts of threads, process of thread creation, and significance of threading module for Python programming. We have also witnessed how multi-threading can be implemented in Python program and can be used for real-world scenarios. We have also learned how to create Twitter and Dropbox applications and access it through Python programming. This application can be further modified to create many other applications such as pollution monitoring or health monitoring or human surveillance or smart buildings where concurrent processing is necessary, where internet can help, and data needed to be stored in the form of a log file. Students can try to control real home appliances using relays. Thank you for watching.